Hi all. Today we're going to be covering threading with Godot nodes. So previously we discussed just distributing asynchronous tasks to essentially offload work to a separate thread using Godot nodes as the starting point. Today we're going to actually cover bringing back in threads and distributing them onto the main thread. So we're going to start off by covering creating an HTTP manager, and essentially what we're going to be doing here is if we look at Godot and we add a child node, there's a specific node called an HTTP request. We can actually just add this onto the HTTP manager, but for simplicity's sake we're going to be just looking at the fundamentals of these. We have something like use threads, body size limit, timeouts, and essentially all this does is this sends out a web request to some other endpoint on the web, retrieves that information, then brings it back after it's been completed. And this is required as a node to be sent off through the main thread. And what you'll come across when you're actually working in Godot nodes, or using Godot and using nodes, is that nodes require that they be executed from the main thread. Everything that inherits from node, as we covered in many previous videos, nodes require that they're executed from the main thread. So by using an HTTP request, this means that this has to be executed from the main thread. And we can actually get around this simply by queuing up information. So we're going to start by declaring this as a sealed class. We're going to remove the ready function. We're not going to be making use of this, but we are going to be making use of the Godot's process function here. So we're going to align this as we do previously. I like to use vertical alignment for my code, so we're going to continue using that. And we're going to be using a couple different namespaces here. We're not going to be using system, but we are going to be using collections.generic. In a little bit here, we're going to be creating a queue. And we're going to start off by creating a public void method that is essentially going to be taking in some information that is related to the HTTP request nodes. So we're going to create a public void function and call this send HTTP request. And all this is going to be doing is basically taking the same amount of information that we would actually be queuing for an HTTP request. So we're going to be actually taking a few different things. We're going to take in a URL. This is the endpoint that we're going to be targeting. We're also going to have a list of headers. So this is anything that is related to, say for example, you need a PNG file. It'd be like image img/png or GIFs, etc. So this is going to be the list of headers. We're also going to have the method, and we're actually going to move this into a separate using because I don't like using dot operators. So we're going to have a using static Godot.http client. This way we have access to the method. The methods relate to any HTTP methods, so things such as gets, puts, posts, deletes. So this is the method that we're going to be using of what we're going to be essentially calling through our application. And then we're also going to have the body information, so the JSON information that we're going to be passing through, whether it's parameters, whether it's information that's requested in an endpoint, etc. And then finally, we are going to have one last thing, which is essentially the callback that's going to be happening when this HTTP request ends up completing. So like I said, it's reaching out to some endpoint. So this isn't executed instantaneously. This is could take milliseconds. It could take theoretically a second. Could even take longer than 5-10 seconds, depending on how much information your endpoint. Maybe your web request might not even complete. It'll complete, but you'll receive an error code. But some of these could actually theoretically take quite some time. So this is actually within the HTTP request completed handler, and we're actually going to access this by doing the same thing we did with the HTTP client. I don't like having nested dot operators, so we're actually just going to be doing request completed handler And this is going to be using the Godot HTTP request completion handler. Mostly because I don't want to have these multiple dot operators. So this is going to be the completion handler. And this is going to be the callback that essentially is saying that when we've finished this, and this actually is not just a parameterless function. If we would take a quick look at this, it'll actually show that we have a couple different things here. We have a long for the result, a response code, which is typically like 404s or 400s or 300s or successes like 200, 204, and a header of the headers that come back with the response in the body. So this is a special function that we're going to be essentially using to add our respond to when our HTTP request has finally been completed. Secondly, we're going to have to wrap this information in some additional holders to maintain this while this is being executed from a separate thread, because what's essentially going to be happening is on our separate thread we are going to be calling send HTTP request, and what's going to happen is we are going to make a private queue that we're just going to call well, let's make our structure first. So we're going to maintain a private structure. It's only going to be used in here. And this is basically going to be the HTTP request data structure. So we're going to make a public HTTP request data constructor. And all this is going to have is the same information that exists in here. We are just passing forward this information and making sure that we maintain it up until we move into the Godot main thread to fully execute this information using the HTTP nodes. So likewise, we're just going to maintain this and push this all forward. So this is just going to be adding semicolons to everything. So headers, URL, and all we're doing here is essentially just passing this information forward. So this is actually going to be what is inside of our queue. And we're just going to name this HTTP request data equals new, and we're actually going to add queue after it just so we know. And for this constructor, C# constructors require that you assign stuff. So we're going to do URL, this dot headers equals headers, this dot method equals method, this dot JSON, etc. And essentially all this is going to be doing is maintaining the information we pass in here. And the queue is going to be maintaining the information so that when we move into the process function, we can actually start sending off these APIs. So when we call send HTTP request, all we're going to simply be doing is adding this information as a new HTTP request. And it's basically just going to take this information. So we're going to have a URL, we're going to have the headers passed in, the method passed in, the JSON information, and the completion handler. And so what this does is now we have moved what is coming from a separate thread into our queue, and now we can actually start to use this information within our main thread. So coming into the process function, we're actually not going to be making use of Delta. It's relatively it's not required for this, but we're essentially going to be doing a dequeue here. So while true, we are actually going to be removing, basically sending out each one of these requests that we've now queued into our function. So we're going to do HTTP request data equals dequeue. And what this is, if you're not familiar with queues, this is the concept of first in, first out. So if you think about a line in a roller coaster, amusement park, first person gets in, first person gets to choose a sheet. If you're at a stoplight, the first car is the first one. The first car at the stoplight is the first one that's going to start moving. It's a very straightforward concept, but if you're not familiar with queues, this is essentially what it's going to be doing. And dequeue pops off the first thing that came in. So we've called send HTTP request. We're now inside process. We've now retrieved the data that we've passed in here. And now we can actually start making use of the HTTP requests. We're just going to call new on this. And what this is going to essentially do is create a brand new node for us. However, we are going to keep track of this node because I do not like having dangling references that just kind of sit there. And so if we do not clean up these nodes, we're going to lose them. So essentially what we're going to be doing is nesting this. Godot is, for those of you that may be coming from Unity, Unity actually updates the editor in real time when you hit the play button. Godot will not do this, so when we run this, we won't see the nodes actually attached to the HTTP manager. But essentially what we're going to be doing is calling add child, and we're going to add these HTTP requests into this node. So basically every single HTTP request over here is going to be essentially nested here as if we called HTTP request and added this on here. And afterwards, so we've created our new HTTP request. We are going to add two separate event handlers. So we have an HTTP request, and there's actually an event called request completed. And we're going to do two things here. We're going to make use of this twice. The first one is going to actually be the request data that we have here. This is going to be the completion event handler that is immediately called from the or what we've basically delegated out however we want to handle these HTTP requests with the information we pulled down. So we're going to start off by just doing HTTP request data, and we're simply going to assign the completion handler. Missing something here. Request data plus equals. Sorry, these are not public, and we need to make these public so they're accessible. So public. So we have completion handler, and this is simply moving the event that we previously had from our separate thread. Secondly, we are going to make use of Godot, C#'s lambdas, and essentially what we're going to be doing here, and you'll see that this is throwing an error. That is simply because we need to use the same parameters that exist for the completion event handler. So we're just going to pass these forward, which is going to be a long result, response code, headers, and body. And all we're going to be doing here is simply managing this particular node. So we're just going to call HTTP request queue_free. This is a Godot method. This is basically what destroys a node. If we do not maintain this, our HTTP manager is going to get bloated with whenever we make an HTTP request, it's going to add the node, and if we do not maintain this, it will permanently keep that HTTP request node on there, and it just it starts to bloat your nodes. So we're going to clean this up. As soon as this request has been completed, we're going to call queue_free. And then finally, we are actually just going to now call request. And all we're going to do is pass forward the rest of the information we have in our HTTP request data. So what we need to do here is simply pass in HTTP request data dot, this starts off with the URL. Then we move into headers, so HTTP request data headers, and also we missed a comma here. The method, so HTTP request data method, and then finally the JSON information, so HTTP request data JSON. And so now we have successfully, and I'm also going to prefix it with the uint because it's impossible for this to be negative. We have now successfully moved our threaded HTTP request onto the main thread, and we are now keeping track of our nodes. So every time we call this, we are now going to be having HTTP request, etc. And this will manage the nodes so that we do not have those dangling nodes just sitting there, because those also are going to be calling process, even though it might not do anything. It still takes computation time, so we're going to clean those up. And essentially, we have now offloaded our HTTP calls to be able to be managed from main threads, or from separate threads. So to take this a step further, so this is fully allowed us to do nodes. You can follow this same format for any other multi-threaded nodes. All you have to do is enqueue whatever node you're happening to do. So you're creating a texture from a separate thread. Well, then you create a texture manager and have a process where you pass in the texture information and then create the texture in the process function. That way it's created within the main thread and can be assigned. And so we can actually make use of this HTTP manager. So we're actually just going to, I work on my Twitch stream very frequently on my Twitch channel, and this is where I came across using the HTTP manager and multi-threading. Because in my world, I have a Twitch manager that operates on a separate thread, processing chat messages that come in, and I need to be able to pull down the PNGs that exist from people's emotes that are coming through my chat system. And so the way to do this is basically by using HTTP managers. So we're going to start off simply by making use of this by adding a child node, and we're just going to add a brand new node, create a brand new script. We're just going to call this example HTTP thread script. It's not really super important. It's simply demonstrating the information. But we are going to assign this information to, we're going to just follow the same standard steps of naming our nodes exactly as the script it's using for simplicity's sake. And we're just going to simply open up this script. We are not going to be doing anything super crazy here. First off, we're going to add the sealed keyword. Nothing's inheriting from this, even if it's not super important. I like to be consistent. We're going to remove our comments, and the only function we're going to be making use of is actually the ready function. We're going to start off simply by using the previous node directory that we have. We are actually going to retrieve this HTTP manager node. So just like all we have in our previous VODs, we're going to do HTTP manager equals get node. It looks like Godot has broken for me, so I'm actually going to restart this real quick and reopen this this thread script. Looks like I lost reference of Godot. If not, I might have to restart the project. Okay, cool. So we're going to call get node. And we are simply going to be using the HTTP manager and retrieving that using our node directory. So node directory dot node pass, and we already have the HTTP manager, and we are actually going to also prevent ourselves from using multiple operators equals node directory dot node type. Just because, like I said prior, I don't like using multiple operators, even if it's just an example. So we're going to start off by simply retrieving the HTTP manager that links to this node here. And then we are going to, and if you're interested in knowing about the node directories, I'll put a link down below and how to set that up. But we are going to simply call task.run. And we're going to make use of C# lambdas again. And all this is going to be doing is simply executing out. We're also going to make this asynchronous. All this is going to be doing is simply making a call to the Twitch APIs. I have a link I'm already going to be using here. And all we're going to be doing is writing out the information that I'm about to pull down from Twitch. So to start, we're going to delay this slightly, delay in milliseconds, just by 1 second, just to give us some breathing room. And we're simply going to call task.delay using the delay in milliseconds. So this is basically going to pause this thread for 1 second so it doesn't execute anything super crazy here. And I'm going to copy and paste this from my other project. So this is the Twitch emote link that we're going to be using here. This is actually the same, I think it's the same icon that is the rainbow. But I'm just going to simply use this one because it's a link I have just currently lying around. And so all we're going to be doing here is actually calling the HTTP manager send HTTP request. This is all we're going to be doing, and this is how simple it is. So we are now on a separate thread. We're calling HTTP manager send request. We're going to pass in the Twitch emote link. This is the URL. We have 0 headers for this. There's no information I need to send to Twitch to get that information. We are going to also do the same thing we did with the HTTP manager, where we statically declared the HTTP client, just so I can do method .get, because all we're going to be doing, we're not posting anything, we're not deleting anything, we're simply pulling down this emote from the Twitch APIs. We're also going to do nothing for the JSON. Typically when you do get calls, you're not going to have to do too much for passing up information. And then lastly, we are going to use another Lambda. And this Lambda is going to be the exact same thing that we used for our HTTP request completed call. This is identical, and it needs to match the signature that is the completion delegate. And this is what's bound to Godot. You can attempt to change it, it's not going to go very well. But this is going to be our completion handler. And for all we're going to be doing here is just do a simple for each var header and headers. And all we're going to be doing is printing out the header information. And we're also going to be doing a print call on the body information. So we can just see this printed out in the Godot console. So we're just going to do we're going to make use of encoding and basically parse the bytes into a string. So get string using the body that's been passed down. So now we have get string. This is going to parse all of the body into a string file rather than using bytes. So it's this one. And secondly, we're just going to call gdprint. We're just going to make use of C# interpolated strings and just output the, well, actually we don't even have to do that. We'll just output the header. So we're going to make a quick call to this. We're simply going to, we're also going to remove the system namespace. We're going to make a quick call to this on ready. This one has already been started. So we can simply make this call and we should see multiple outputs. In fact, well, I'm not going to put a breakpoint, but if you really wanted to, you could run this in Visual Studio. But we're going to make a simple WinHttp call. This is going to start an application. And you can see over here that we have now, this is the information. Actually, let's take this a step further, just so we can, we are going to make use of the interpolated strings just so we can kind of understand that this is the header and this is what's the header and what's the body. Header, and we'll just do another interpolated string. This one will be body. And we'll just call this, because I don't like having stuff like that, interpolated strings like that, we'll do encoding, body as string equals the encoding, and do the body in here. So we have body as string, and the interpolated string, and our print call. And if we run this one more time, actually move this all over too. Just to maintain, it's good practice even if it's a tutorial video. Never be lazy when you're coding, even if it seems like it's easy, it'll pay off in the long run. So we can see here we have a bunch of headers. In fact, our body failed the get string. Well, it didn't fail the get string. The information that's parsed in there is a you can look into this if you really want to go into the RFCs, but essentially what the body is a compressed byte file, so it's actually not going to parse correctly. That's a whole separate can of worms that maybe I might do a VOD on. If I do, I'll put a link down below, but decoding in PNG is not non-trivial. But we can also see all the different headers that exist. For example, this is an image PNG. The content length, there's a total of 1959 bytes, which are compressed in this body. We can see when we access this, when we no longer can access this, etc. And this has all been created from a separate thread. So we have successfully demonstrated that we can now multi-thread our nodes, or rather use the nodes that exist within Godot, because the HTTP request is a Godot node, and it requires that it's the HTTP request is executed from the main thread. So we can now make our create our HTTP calls. They are still going to be executed on the main thread, but we can queue these, create the Godot objects from separate threads. All we have to do is take that separate thread and link it into a main thread. And it's this fundamental thing that you can do. So this is an HTTP manager. Like I said, you can do this for, maybe you have a texture manager. You can load in your textures dynamically, or rather on a separate thread, and bring those into the main thread or assets or whatever, you know, let your mind wander. But if all follows the same familiarity, where essentially you have a function, you add it to some data structure to keep track of, and you execute that creation of the node on the main thread. So hopefully this helps. This will work super well for managing multi-threading within the Godot engine. So hopefully this helps, and good luck in your Godot adventures. Cheers.